Hello one and all, welcome to the Math Magic Show. In this one, let's take a look at finding the value of this integral. So I'm integrating here between 0 and 1/2, and it's dx over x squared minus 1 times x plus 1. I already have the work written out just because it saves time that way. Let's go through the steps carefully nevertheless, as if I were writing it for the first time. So the first thing is to observe that on the bottom you have a trinomial. So what you can do is rewrite it by completing the square. So then you can apply the inverse tangent function. So let's take a look. I'm going to go through the process here of x squared minus 1x plus 1, and I'm rewriting it with completing the square. What that means is follow the arrows as the following. That this is negative 1. So you take 1/2 of the negative 1, and that gives you negative 1/2 in this position. Put parentheses around everything. And then here you just put whatever the variable is, like x for example. That's the first stage. So that gives you x minus 1/2. That quantity is squared. Follow the arrows. Because if you expand x minus 1/2 and you square that, it's going to give you an extra positive 1/4 at the end. That's not present in the original expression. You have to cancel that off. So we do that always by taking whatever this quantity is right here. So in this case it's 1/2. And up here you square it. And then you take it away through subtraction. So this step here is always subtraction. Just remember that. So it takes minus 1/2 in that position, and you add the 1 from this position right here. So that's the original trinomial part. So we have our expression. Now let's just clean it up a little bit. We need to work out the value of negative 1/4 and 1/2. So let's do that next. When I do that, I have negative 1/4 plus 1. I'm going to take the 1 and I'm going to rewrite it as 4/4. So this over here, it looks like a U, but that's a 4, okay? It's 4/4. That's my way of writing it. And now you have negative 1 plus 4, which is 3, and then you copy the 4 in the bottom. So that tells you that this piece above my head, negative 1/4 plus 1, is 3/4. So I would have x minus 1/2, that quantity squared, plus 3/4 as the new bottom to put in the denominator of the integrand. So let's go through that process. So that looks like this right now. I'm keeping the same limit, 0 to 1/2, but I'm rewriting the bottom, as I said, as x minus 1/2 squared plus 3/4. So this takes care of completing the square. And now I want to clean this up. So let's take a look at what I mean here. What I've done is, when I have 3/4 over here, I'm going to rewrite that first as follows. So I have 3/4. I'm going to write it on the bottom over here as follows. The 4 is equivalent to 2 squared. And take a look. This 3 that you see up here, that's equivalent down below to the root of 3 squared, because the root of 3 squared would give back 3. And the 2 squared would give back the 4. So I've written it this way. And the limits are 0 to 1/2, the same as before. The only thing is I've somehow lost the 1 here above the 2, okay? But pretend that it's there. Okay, so I'm rewriting by completing the square. Let's go on to the next step. So the next step will look like this. Up here, I'm going to do something, and I'm going to try to explain it so it doesn't seem like some arbitrary thing. So to make this conform to the basic rule, hopefully as much as possible, that we use for the inverse tangent function when you do integrals and such, what I'm going to do is I'm multiplying x minus 1/2 squared by the root of 3 over 2 squared over the root of 3 over 2 and the quantity squared. I can do that because this quantity where I'm pointing, that's just equal to 1, isn't it? It's a thing divided by itself. It's equal to 1, you see? Once you realize how many different ways the number 1 can be used in how many different places, it's magically powerful. And I've chosen this particular form of it for the following reason. Over here, as you can see, I have the root of 3 over 2, and that quantity is squared. That's why over here, next to the x minus 1/2 squared, I use that same thing. And the benefit is that you see the portions that are in blue can now be factored and placed outside the integral. So let's take a look at that. I'm doing that down below. So this quantity, 1 over the square of the root of 3 over 2, has been factored outside. And here, let's go carefully through this. Let me zoom in a little bit, or zoom out rather, so we can see more of it. This part kind of above my head, that went out. That's why down below, over here, this has only a 1 left in that position. For this part, on my right, okay, so I guess on my right, but that looks like your left. That number in blue, the root of 3 over 2 in blue, that also goes out, which means that the 1 in the bottom, the root of 3 over 2 squared, that stays. So that means down below, what I have is the following then. The 1 is in this position, x minus 1/2 squared. And under it, I have the root of 3 over 2 and that quantity squared. That's like saying that you can take this one right here, the root of 3 over 2 quantity squared, and place it under this one, x minus 1/2 squared, because this is just these are basic rules of the way you multiply and divide fractions and numbers and such. So that gives me this step right here. Now I observe something important, which is that for this term here, over here, I have x minus 1/2 quantity squared, and I have also under it the root of 3 over 2, that quantity squared. And because they both have a square, you can pull the square to the top of an exponent. And then also, above my head where it says 1 over the root of 3, that quantity over 2 and then squared, you can distribute the 2 there to the root of 3, which would give you 3. And then you can distribute the little 2 in the exponent to the 2 in the bottom, which would give you 4. So you would end up with 1 over 3 over 4, okay? So 1 divided by 3/4, in other words. And I do that right here at this next stage. So take a look. In front of the whole integral, I have 1 divided by 3/4. And as I said, over here now, I have x minus 1/2 over the root of 3 over 2, and that whole quantity is now squared. These are all just fundamental rules of exponents. The limits have not changed, 0 to 1/2 still. Let's go on to the next stage here, so let me zoom over there. So, at the next stage, is basically I took that 1 over 3/4, and in front of the whole integral, I wrote that as 4/3, because 1 divided by 3/4 is 4/3. Also in the bottom, I took that the root of 3 over 2, and I flipped it by the basic property of fractions, so that becomes 2 over root 3 multiplying x minus 1/2 squared plus the 1 that you see there. So let me zoom out here, just compare what I'm explaining. So this step above my head has the root of 3 over 2, so you flip it, so it becomes 2 over root 3 multiplying the x minus 1/2, okay, by keep, change, flip. And the same applies to here where it says 1 over 3/4, keep, change, flip, it becomes 4/3. So I see that down below right here. Now at the next stage, I recognize that at this point, I can use variable substitution. So let's see how that operates. What I'm going to do is I'm going to let u equal 2 over the root of 3 multiplying x minus 1/2. Now, because I'm using variable substitution at this point, because I want to make the integral conform to the rule for the basic inverse tangent function, I'm going to differentiate. So when I differentiate, I'm going to have the 2 over the root of 3 stays, the x differentiates to 1, and the negative 1/2 is a constant, so that goes away. So that just leaves on the bottom under me there 2 over the root of 3 dx. And that's equal to du. At this point, the next stage is to transform the limits of integration. So let's go through the process. Remember that this quantity above me there, that gives me what u is. In other words, I got to replace x with 0 and also with 1/2. I got to transform the limits of integration to the variable u using the quantity above me. So to do that, let's take a look. I go back to the top, and also I am solving for dx. So remember, on the bottom we said that du was equal to 2 over the root of 3 dx. So kind of when you cross multiply, it tells you that dx is equal to the root of 3 over 2 du instead. Okay, so that's going to allow us to replace dx. Perfect. Now let's do the limits of integration. So here, to work that, I'm going to let x equal 0 first. The lower or limit of integration in this integral on the left side here. So when I do that, I'm going to have u equals 2 over the root of 3. Or I replace x with 0. That means the 0 will go away. And then I'm going to have the following. 2 over the root of 3 multiplying negative 1/2. Then the 2's will cancel. And I have a negative 1 multiplying basically 1 over the root of 3, which will be negative 1 over the root of 3. So that becomes the new lower limit of integration. Let's repeat that also in for the other 1/2. So I'll have x equals 1/2. I'm going to transform that. So u equals 2 over the root of 3. 1/2 minus 1/2. I'm replacing x with 1/2. Of course, here that's going to give us the following. 2 over the root of 3. 1/2 minus 1/2 is 0. 2 over the root of 3 times 0 is 0. So that becomes the new upper limit of integration, 0. So let's plug all of these and rebuild our integral. So what I have then is the following. I have 4/3 from flipping. I've got the lower limit of integration now set at negative 1 over the root of 3. Then I have 0 as the new upper limit. I also have the replacement of dx with the root of 3 over 2 du. And on the bottom, I have u squared plus 1 because I replaced with u as the new variable. So this new integral expresses the original one, but only in terms of the variable u. So we have to change the lower limit of integration, the upper limit of integration. We have to rewrite dx, and we have to rewrite the function in terms of u. Those are usually like the four major pieces when you do this. So the next stage, what I'm going to do is I'm going to take that constant being applied to the du and just place it outside the integral. Let me do that down on the next page. So that's going to look like this. So I pull the root of 3 over 2 outside. That leaves me only du. And in the bottom I have u squared plus 1. The limits of integration are shown. And now I observe something, that 4/3 times the root of 3 over 2 means that the 4 and the 2 can be simplified. You can divide 2 from each one. So at the next stage down below, I'm going to have 2 times the root of 3 over 3. So again, that's because 4 divided by 2 is 2. So I have 2/3 times the root of 3, as showed down below as the first factor there in front of the rest of it. Now I apply what I know about the inverse tangent function. So when you see an integral like this one here, where it says something like u squared plus 1 or something along those lines, you can simply differentiate using the inverse tangent. So I have, remember, on the bottom I have a quantity plus another quantity, okay? So when I do that, I will have tangent inverse of the upper limit, which is 0, minus the tangent inverse of the lower limit, which is -1 over the root of 3. Now this you can find either, for example, by using the unit circle or just from remembering the basic tangent function, inverse tangents, and so on. So in our case, it's going to look like this. I have the 2 root 3 over 3, the tangent inverse of 0, which comes from here. The tangent inverse of 0, that's going to be replaced with 0, because remember what the tangent inverse function says. It says, what is the angle whose tangent is 0? So that's 0, okay? The tangent inverse of -1 over the root of 3, that's going to give you over here negative pi over 6. In other words, at negative pi over 6, the value of the tangent is 1 over root 3, and the quantity is negative, okay? Lastly, let's work through the rest of this. So I will have the following. I'm going to take the 2, and I'm going to cancel with the 6. That's going to give me this step where I'm crossing off the 2 here, getting a 1, and then 6 divided by 2 will give me a 3. The root of 3 stays, the other 3 by itself stays, and the pi also stays. And remember that because this is minus a negative pi over 6, it becomes pi over 6 positive. So once I simplify it, at the very last step, I get the root of 3 pi over 9. That's a way of writing the answer. You might also see, for example, where it's not rationalized and the root of 3 is in the bottom, just so you're aware of that. So let me just zoom out. Hopefully I can squeeze most of them, even if they're small and hard to see. Okay, well, that could be very hard to see. I appreciate that fact, but at least it's all visible. Maybe I can improve it a little bit. Thank you so much for watching. Please leave a like and subscribe, and I will see you in another video.